Alright, November 2019 O-Level Chemistry Revision Series. So this is November 2019. So we are on number 3. So if you haven't checked on our previous session, we did number 1 and number 2. So now we are on number 3. So let us dive into the question. So we're given that the chemical equations, we've got the chemical equation X and the chemical equation Y. And then we are required to name the type of the reaction X and the type of the reaction Y. So as I've alluded to that, we are not here to claim answers, but we want to broaden our foundation in terms of chemistry and to understand the deeper and the fundamental principles of chemistry. So I'm not going only to highlight the answers, but I want to explain any related or any topics within the radius of a given question, right? So here we've got this equation for titration. So titration, we did titration for number 1 question, so we're not going to spend much of our time on the reaction X. So the reaction X is the neutralization reaction, right? And then this number B, the reaction Y, is what we call the displacement or the redox reaction. So displacement, a subtype of the redox reaction, right? And then we want to explain what a displacement reaction is. So a displacement reaction can be defined as the reaction where the more reactive element displaces a less reactive elements from its compound. So a more reactive displaces a less reactive. So this is the definition for a displacement reaction. So it is a subtype of a redox reaction where reduction and oxidation both takes place, right? So we have already called the reactive series both for the cations or both for the metals and the non-metals, right? So for the metals, the group 1 metals are more reactive, and then followed by the group 2, and lastly with the group 3. So that's the general trend you need to know. And also there's this reactive series where we have potassium. First we have barium 2 plus, then potassium, and then sodium, and then calcium, and then magnesium, aluminium ion, plus, and then zinc 2 plus, and then iron 2 plus, and then tin, and then lead, and then the hydrogen ion being the reference. So we need to highlight hydrogen with a different color because hydrogen is our reference point. So when measuring atomic masses, we say with respect to carbon 12 atoms. So for electropotentials or reactive series, we refer to the hydrogen ion. So you understand it when we are doing electrochemistry for the A levels, right? So for O level, you simply you have to understand or to claim this reactive series, right? So this is the reactive series, right, for the metals or the cations. And then for the anions, we have this fluorine or the fluoride ion, and then the sulfate ion, and then the nitrate ion, right? And then the chloride, the bromide, the iodide, and then lastly we have got the hydroxide ion. So the tendons for electrolysis, you should know that the tendons of discharge increases as we go down the globe. So for electrolysis, right, should highlight this. The tendons of ion to discharge increases as we go down the series, increases ongoing series, right? So in our video for the electrolysis, in our session, we said electrolysis is governed by three terms: preferential discharge, concentration, and the type of electrode. So this is what we call the preferential discharge of ions. So this is the reactive series. So this one is the trend of discharge, meaning to say fluoride ion is more reactive than the hydroxide ion in simple terms as you go down the group. So you should know it in this simplified version. The rate or the feasibility of the reactions decreases as you go down the series, right? Meaning to say barium is a stronger reducing agent than copper and etc., right? And then sodium is a stronger reducing agent than tin. Then the fluorine is a stronger oxidizing agent than iodine, than the oxide, than the sulfate, and then the sulfate. So you should understand the term oxidizing agent and reducing agent, right? And also remember to how to write the half equations for both. So this is much applicable in electrolysis when we write the half equations, right? So we are going to wrap this for the purpose of the question, right? So we are now on number 2. So this is neutralization, and then this is displacement reaction, right? And then describe and explain the effect of doubling the volume of hydrochloric acid to the reaction X, given that we are given that 0.05 moles of each of the reactants were present, right? Were initially present. So the effect of doubling, so we should know that these two, the sodium hydroxide and the hydrochloric acid, react in a ratio of 1:1. And also remember that for every acid-base reaction, the neutralization reaction, we've got this overall equation, which is an exothermic reaction with an enthalpy change of about 57 kilojoules per mole. So you should know that for every acid-base reaction, the neutralization reaction, we've got this ionic equation where 1 mole of water is being produced from the proton and the hydroxide ion. So nowadays in exams you can be asked that an organic acid X react with the sodium hydroxide, write the ionic equation for the reaction. So you should know that this is the main ionic equation for the neutralization reaction, right? So the effect of doubling sodium hydroxide, we've got excess hydrochloric acid which remain reacted, right? So since the two are reacting in the ratio 1:1, doubling the hydrochloric acid will cause the hydrochloric acid to remain unreacted. So we have excess hydrochloric acid within the reaction chamber, right? So the explanation, we can say sodium hydroxide is the limiting reactant, right? Or we can say hydrochloric acid is in excess. Then we now move on to the next equation. So Fig 3.1 shows copper 2 nitrate being heated in a test tube. So we've got the test tube, so copper 2 nitrate in the solid phase, and then the test tube hold, and then the test tube. So we've got this equation. So you should know that the decomposition of metal nitrate will give the metal oxide. So you've got the metal oxide, right? And then for lithium, we have lithium oxide, right? And then for sodium, we've got sodium nitrite. So you should know the trend, right? So you should know the trend for the decomposition of the nitrates, right? And then the name the product X. So product X, we've got copper 2 nitrate, right? Copper 2 oxide, right? So we've got copper 2 oxide with the formula. This is the formula for copper 2 oxide, right? And then we are required to determine the value of coefficient Y. So we can find this value by simply balancing the equation. So we can rewrite the equation to say copper 2 nitrate to give 2 moles of copper oxide plus nitrogen dioxide plus oxygen. So to balance this equation, we simply need to have a 4 here. So the value of Y is equal to 4. And then state any observable change that can occur during the reaction. So nitrogen dioxide is a brown gas, so a brown gas is evolved, right? So a brown gas is evolved. So this is the observation. Or we can also say that a black, so copper 2 oxide is black in nature, right? So a black solid is observed, right? A black solid, right? So we are now moving on to number 4. State any 2 human activities that contribute to emission of carbon dioxide into the atmosphere. So we have got deforestation increases the concentration of carbon dioxide, since carbon dioxide is one of the raw materials we can use in photosynthesis. So by deforestation we reduce photosynthesis, thereby increasing the concentration of carbon dioxide into the atmosphere. And then the combustion of fossil fuels, so like coal, fossil, so burning or combustion of fossil fuels, e.g. coal, natural gas, right? And then describe 2 environmental effects of high concentration of carbon dioxide in the atmosphere. So we are guided by the term environmental effects, right? So we want the effects of carbon dioxide to the environment. So we've got global warming, which is defined as the continuous rise in temperature, right? Global warming. And also we have got ocean or aquatic acidification, right? So aquatic acidification or ocean, since carbon dioxide is an acidic oxide, it readily reacts with water to form what we call carbonic acid with the formula C2CH, right? So this is the formula of carbonic acid. So this increases the concentration of protons in the water bodies. So since pH is defined as the measure of hydrogen ion concentration within the solution, the pH of the ocean is being altered. So this affects the aquatic environment. And then we are required to explain 2 ways that can be used to reduce the amount of carbon dioxide in the atmosphere. So we can use greener or renewable sources of fuel. So we can use renewable energy or green energy, and then we can reforestation, right? And then name other 2 gaseous pollutants that can be emitted into the atmosphere. We have got sulfur dioxide, sulfur trioxide, and then nitrogen oxides. So nitrogen, we've got nitrogen monoxide, nitrogen dioxide, dinitrotetraoxide, right? So you can simply say nitrogen or X here to simplify that. You're saying nitrogen oxide, since there are many in number. And then we also have carbon dioxide, we also have soot, right? And then we are on number 5. So number 5 says Fig 151 shows a setup of an investigation that was carried out in a laboratory, right? So we've got cotton wool soaked in concentrated hydrochloric acid, and then cotton wool soaked in concentrated ammonia, and then the rubber stopper, So the first question says describe and explain the observable changes that occurred. So the observation, so this question is from the topic of diffusion. So you're being examined on the rates of diffusion, the effects or the factors which affect diffusion. So according to, say, Graham's the law of diffusion, which says the rate of diffusion is inversely proportional to molar mass, right? So this is the, say, Graham's law of diffusion. So if the mass increases, the rate of diffusion decreases, and then if the rate of diffusion increases, we have a smaller mass, or the particles in question are lighter in mass, right? So here we've got hydrochloric acid and ammonia. So the molar mass of hydrochloric acid is, or hydrogen chloride gas, so in gaseous phase it is called hydrogen chloride, and then in dissolved or in aqueous phase it is called hydrochloric acid. So it's one and the same thing, right? So the molar mass here is 35.5 from chlorine, and then plus 1 from hydrogen, and then here we have 14 from nitrogen and then 3 from hydrogen, so it's 17. So this ammonia is lighter than this hydrogen chloride gas, so meaning to say this ammonia diffuses faster than hydrogen chloride. So diffusion is defined as the movement of particles from the region of higher concentration to the region of lower concentration. So it is a passive transport system, right? So you should know diffusion inside out, right? So we want to plot or to highlight the point of reaction here. So when the two particles meet, or when the two particles come into contact, that's where the reaction occurs. So hydrogen will travel at a slower rate, meaning to say it will travel a shorter distance within the chamber, the reaction chamber, right? And then ammonia will travel faster, meaning to say it will reach the region of lower concentration at a faster rate. So hydrogen chloride is more concentrated here, meaning to say it will move down the concentration gradient to this side, and then so the direction of hydrogen chloride will move towards where ammonia is. That's where it is less concentrated, and then ammonia is highly concentrated here, meaning to say it will move to the regions of lower concentration, right? So here we've got ammonia traveling faster. Why? Because it is lighter in mass. So the reaction will occur around this region, right? To show that ammonia travels a longer distance since it is traveling faster, right? And then hydrogen chloride will travel a shorter distance. Why? Because it is traveling at a slower rate. So the rate of reaction is governed by concentration, by temperature, and by molar mass. So concentration, temperature, and molar mass. So you should know these three with respect to diffusion, right? So this is the point of reaction. So the two will react according to this reaction. So is hydrogen chloride plus ammonia to give ammonium chloride, right? So this is the reaction, the equation for the reaction. So these two are in gaseous phase, and then this is in solid phase, right? So what we observe a mist of hydrogen or of ammonium chloride. So this is the observation we can tell, right? So you should also note that ammonium chloride is formed near the pore or near the end where you have hydrogen chloride, and I've explained why. So that's what you should know. So in your multiple choice questions, they can examine you by saying this is the point A, this is the point B, C, and then D. So you can be asked to tell the point where the ammonium chloride is formed. So ammonium chloride is formed at A, not at B. Why? B is the halfway. So halfway means we are saying that the rate of diffusion of hydrogen chloride is equal to the rate of diffusion of hydrogen chloride, which is not true, since the two have differ mass numbers. And then at point C, we are saying that hydrogen chloride travels faster than ammonia, right? So point C and point D are very, very false, and you should stick to the point A. And also you should be able to explain why point A is the correct answer, right? And then we go back to our question. Explain the observation. So what you observe are the white fumes, right? Which are formed near HCl end, right? So this is the observation. And then to explain, we can say ammonia is lighter with a mass of 17. So this means it diffuses faster than the FVM and the HCl with a mass of 36.5, right? So this is the explanation. And also to write the equation, this is the equation, right? So we have done that part. And then the next part is state any two conditions that will affect the time taken for the change to be observed. So time taken, this is the rate of reaction. So I've said the rate of reaction is governed by three terms. So we've got concentration, temperature, and the mass. So this is what you should provide for your answer. State two condition, mass and temperature, right? And then concentration. And also you should be able to explain. So temperature is governed by the kinetic theory of matter. Increase in temperature increases the collision, increases the particles with the amount of energy, activation energy. So that's reaction kinetics. So we're going to cover that when we are going to do reaction kinetics. And then state one use of the product, the use of ammonium chloride. You can use ammonium chloride as a fertilizer, right? So that's the use of ammonium chloride. So we can use it as a fertilizer since it can provide nitrogen to the soil, right? And then describe the process of the two causes of eutrophication. So the two causes of eutrophication, agricultural runoff or increase in the concentration of fertilizers, and then sewage discharge, right? But we want to explain that process of eutrophication, because this year they are requiring you to give the two causes, but next time you're going to be asked to explain the whole process of eutrophication. So here we're not here to claim answers, but we want to broaden our knowledge, right? So eutrophication is defined as the process whereby the water bodies become overly enriched with the nutrients, mainly the nitrogen and the phosphorus. So we can say eutrophication, it is the process where water bodies become overly enriched with nutrients, mainly nitrogen and phosphorus. So you should write in words, not in chemical symbols, right? And then for the whole process, first we have the excess nutrients from the, so let me write it over here. So first we've got excess nutrients from the sewage, the fertilizers, right, and etc. And then the second step, so this is the first step, and then second, this will cause, or this will result in the rapid or the algae bloom, in the rapid growth of algae, which is called the algae bloom, right? And then third step, when algae die the bacteria will decompose this algae and then depleting the concentration of oxygen, right? The bacteria will decompose them, thereby using oxygen in the water bodies, right? And then step number 4, this will result in oxygen depletion, right? So oxygen levels drop, leading to oxygen depletion, right? And then the last step, loss of aquatic ecosystem or aquatic life, right? Due to lack of oxygen. So this is the process of eutrophication. So you should be able to explain the process of eutrophication. And then now we are now moving on to section B of the paper. So